Quantum mechanics. In quantum physics, there is a concept that says that very small particles, such as electrons, can be in many places at once until someone sees them. This phenomenon is called superposition. This sounds strange because in our daily lives, objects are only in one place at a time. Hugh Everett III, a physicist, offered a theory to explain this in 1957 called the many worlds interpretation, which can be read in his book, The Theory of the Universal Wave Function. He suggested that whenever there is a choice or possibility, the universe branches out, creating another version where each possibility occurs. Imagine you are faced with two simple choices: drink coffee or tea. According to Everett's theory, when you choose coffee, there's another universe that forms where you choose tea. So both choices happen, but in different worlds. In other words, in one universe you drink coffee, while in another universe you drink tea. This theory states that every decision, big or small, creates a new universe with different possibilities. Although difficult to prove, Everett's theory has become a basis for discussion in physics and philosophy, challenging us to consider that there are other versions of ourselves that may be living different lives in other parallel worlds. Cosmic inflation theory. The cosmic inflation theory was developed to explain how our universe expanded so quickly shortly after the Big Bang. According to this theory, our universe expanded at an incredible speed in a very short period of time, just after it was formed. One of the main figures who developed this theory was physicist Alan Guth, who introduced the idea of cosmic inflation in his book, The Inflationary Universe. However, some scientists argue that cosmic inflation created not just one universe, but many universes, each separate and independent. This concept is called the multiverse. It is like a bubble balloon that bursts and creates many bubbles. Each bubble is a separate universe with its own laws of physics. In this theory, our universe is one bubble among many others formed during the inflation process. This theory is interesting because it explains why our universe is so perfect for life in a multiverse. Only a few universes have the conditions to support life as we know it. String theory. String theory is a theory in physics that proposes that fundamental particles are not tiny dots, but rather very small strings that vibrate at specific frequencies. Each vibration of these strings determines the type of particles produced, similar to how different tones are produced by guitar strings plucked at different frequencies. String theory is very popular in physics because it offers the possibility of unifying different theories of how the universe works. One development of string theory is M theory, which was introduced by physicist Edward Witten. In M theory, our universe is thought of as a brane membrane that exists within a higher dimensional space. M theory states that other branes can exist around our universe, each forming parallel universes with different characteristics and laws of physics. The universe can be thought of as a sheet of paper floating in a vast pond of other sheets. Our sheet is our universe, but there are other sheets floating along, each of which represents a parallel universe. Each of these branes or sheets is its own universe, and although they exist in the same space, we can't see or touch them. This theory offers a way for scientists to think of reality as a wider array than we can observe. Although this theory is still highly speculative and difficult to test directly, M theory and string theory open up the possibility that we live among many other universes in a vast and complex multiverse structure. Quantum entanglement. Quantum entanglement is a phenomenon in which two connected particles can communicate with each other instantly, despite being vast distances apart. For example, if two particles are quantum entangled, changes that occur to one will immediately affect the other, even if they are on different sides of the universe. Albert Einstein called this phenomenon spooky action at a distance because it contradicts the law of relativity, which states that no information can travel faster than the speed of light. Some scientists argue that quantum entanglement could be evidence of parallel worlds. According to this theory, entanglement is possible because two particles are in different but connected layers of reality. In parallel world theory, entanglement can be understood as a window that allows interaction or seeing between two different universes. A simple example is when we have a pair of cards in two different rooms, one card in room A and another in room B. If we turn over the card in room A and find the result, at the same time the card in room B shows the opposite result, even though there is no direct communication. Some scientists suspect that this connection might be because the two cards are connected in a parallel reality. The phenomenon of quantum entanglement is still difficult to fully understand, but it opens the door to the idea that there are hidden connections between our reality and other realities that we cannot see. Black holes. A black hole is a region of space that has gravity so strong that anything that crosses its boundary, called the event horizon, cannot return, not even light. Scientists like Albert Einstein and Nathan Rosen developed this concept further in 1935, introducing the possibility of wormholes, or space-time tunnels. In this theory, wormholes function as bridges connecting two different points in space and time, or even two universes. In the concept of parallel worlds, black holes and wormholes offer the possibility that we can explore other universes through these passages. If wormholes really exist and can be stabilized, they can be portals to other worlds that are parallel to ours. While most wormhole theories are still theoretical and have yet to be proven experimentally, scientists are studying black holes around the centers of galaxies to understand their potential as doorways to other universes. One of the largest black holes ever studied, Sagittarius A, at the center of our galaxy, is the target of these observations because it could provide clues about the structure and behavior of black holes. If stable wormholes can be found or created, they could open up new ways for us to connect with other universes or even explore parallel worlds, although the technology to do this is still far from our reach at the moment. The Mandela Effect. The Mandela Effect is a phenomenon where many people collectively remember events or details in a way that differs from the actual historical record. The name comes from many people remembering that Nelson Mandela died in prison in the 1980s when he actually died in 2013 after becoming president of South Africa and living as a respected figure. This phenomenon has attracted attention because there are many similar instances where people remember details that differ from recorded reality. Some other examples of the Mandela effect include people remembering the title of a cartoon show as Looney Tunes when it was actually Looney Tunes, or remembering the name of a popular children's bear as Berenstain Bears and when it was actually Berenstain Bears. This phenomenon has led many to wonder if our memories can be affected by the existence of other realities. A more speculative theory suggests that the Mandela effect could be evidence of parallel worlds. According to proponents of this theory, it's possible that some of our memories come from other versions of ourselves living in slightly different parallel realities. This means that in some universes, Mandela might have died in prison, or the bear was indeed named Berenstain. While this theory lacks solid scientific evidence and is still considered a hypothesis, the Mandela effect has sparked an interesting discussion about how parallel worlds can affect our memories. The mathematical universe hypothesis. Some scientists argue that mathematics itself may contain clues to the existence of parallel worlds. One interesting theory proposed by physicist and cosmologist Max Tegmark is called the mathematical universe hypothesis, which states that the universe is not just explained by mathematics, but is mathematics itself. According to Tegmark, all possible mathematical structures can be realized in real form. In other words, every possible combination of natural laws that may exist in mathematics can produce a universe with different physical rules. Thus, if a reality can be defined mathematically, then it really exists in a different universe. You can imagine a world like a video game with laws and rules created using math. If each mathematical rule can create a different reality, then each possible rule can form its own universe that runs parallel to ours. In Tegmark's theory, each of these realities is real. It just exists in another dimension or at a different level of existence. This theory offers the unique view that there are infinite universes, each governed by different mathematical rules. Although this is still a hypothesis without direct empirical evidence, the mathematical universe hypothesis has opened up new perspectives in cosmology and philosophy, providing an explanation that parallel worlds could be the result of all the possibilities of mathematics. The anthropic principle. The anthropic principle states that our universe seems so perfect for life because we are in it to observe it. In simple terms, this means that we exist in a universe that is suitable for life because otherwise we wouldn't be here to observe its existence. Many scientists use this principle to explain the phenomenon of fine-tuning in the universe. This fine-tuning refers to the fact that many physical constants, such as the strength of the gravitational force or the speed of light, are at very specific values to support life. If any of these constants were even slightly different, the universe would not be able to support life as we know it. But why is our universe so precise? One explanation is the multiverse or parallel world theory, which states that there are many other universes with different variations of the physical constants. Most of these universes may not be capable of supporting life, but ours is one of the few where conditions favorable for life happen to exist. Think of it like a big lottery, only a few out of billions of tickets win, and we happen to be on one of those winning tickets. In other words, the anthropic principle states that the universe suitable for life is the one we live in because of the many other parallel universes that might not support life. This concept makes it easier for us to understand why this universe seems so perfect for life, because only in this universe can we ask about its existence. Simulation hypothesis. The simulation hypothesis, popularized by philosopher Nick Bostrom in his essay, Are You Living in a Computer Simulation? In 2003, proposed that the universe we inhabit could be a simulation created by intelligent beings in another universe. According to Bostrom, it is possible that highly advanced civilizations have the technological capability to create simulations that are so realistic that the inhabitants are unaware that they are in a simulation. Bostrom mentions three scenarios. First, advanced civilizations may not be interested in creating simulations. Second, they may become extinct before they can achieve this. Or third, they actually create many simulations, which means there is a good chance that we live in one of these simulations. If the third scenario is true, then our world is just one of many simulations, which can be likened to a parallel world. A simple example is a computer game that simulates life, such as The Sims. In the game, the characters live in a simulated reality shaped by the creators, and they may not realize that they are just part of a digital world. If we also live in simulations, this means that there are many other worlds or simulations running in parallel to ours. This hypothesis, although still theoretical and difficult to prove, has attracted the interest of scientists and philosophers because it opens up the possibility that our universe is not the only one, but rather one of many simulated realities that exist. Near-death experience. Near-death experiences are events where a person on the verge of death reports sensations of going out of the body, seeing bright lights, or even meeting spiritual beings or deceased people. These experiences have attracted the attention of scientists and spiritual experts, as they often suggest the existence of another reality beyond the physical realm we are familiar with. Some researchers, such as Dr. Raymond Moody in his book Life After Life, have collected many accounts from people who claim to experience a different world as they near death. In some cases, they felt they entered another dimension of peace or met figures that could not be explained in terms of ordinary reality. These experiences are often described as other realities that seem real and visceral. Parallel world theory sees these near-death experiences as possible windows into other dimensions or parallel universes. According to this view, human consciousness may be able to interact with or see other realities when under certain conditions, such as on the verge of death. While there is no solid scientific evidence to confirm that near-death experience actually take us to parallel worlds, this phenomenon continues to be a subject of research and discussion. For many, these experiences hint that there are many layers of reality beyond what we can see, and parallel worlds may exist between those dimensions, waiting to be explored by human consciousness.